In this video, we're going to learn how to figure out what the empirical and molecular formulas are if you're given lab data, like percent data. We're going to figure out how to determine what the empirical formula is, and then with more information we can figure out the molecular formula. So just for recall, an empirical formula is the simplest ratio of elements in a compound. It cannot be simplified any further. So we are going to analyze the compound and figure out the formula. Given the following information, it has 36.5% sodium, 38.1% oxygen, and 25.4% sulfur. Notice that everything adds up to 100, which it should. In order to figure out the formula, it has to. And we often have percent data because there are pieces of lab equipment that you put in some mystery compound and it will tell you the mass percent, called a mass spectrometer. The first step is to assume that we have 100 grams of compound, because then we can turn our percent symbols into grams. So change the percent, don't have to do any math, just change the symbol from percent to gram. So then we would write 36.5 grams of sodium, 38.1 grams of oxygen, and 25.4 grams of sulfur. Now that we have the grams, we can then figure out the moles. So in the next steps, we're going to convert from grams to moles for each element using its molar mass. That's the next step. Okay, so now where we had grams of sodium, sulfur, and oxygen and sulfur, we've divided each by its own molar mass. So for sodium it's 23, for oxygen we divide by 16, and for sulfur we divide by 32, which gives us the number of moles of each element in our compound. This is the mole ratio. However, we're not allowed to put decimals in a formula, so the rest of the work that we're doing is going to be to convert these decimal ratios to whole number ratios. So the next step is to divide each number by whichever one is the smallest. So in this case, the smallest number is 0.7938. So we're going to divide each number by this smallest number. And don't forget that in the middle, you want to keep at least 4 sig figs on all your numbers. You don't want to get rounding errors. Okay, so we've divided each of our moles by 0.7938, which means that sulfur is going to be 1 because it's divided by itself. The other two, I get 1.99, which is super close to 2, rounds to 2. And I get 2.99, which is really close to 3, and that rounds to 3. You can round the numbers if they are really close to whole numbers. If they're not really close, you cannot round them. You might have to do more adjustment. In this case, our formula is 2 sodiums, 3 oxygens, and 1 sulfur. That is our empirical formula. Because it's usually written, sulfur and oxygen is a polyatomic that's usually written SO3, I did rewrite it as Na2SO3, and that's the empirical formula, which is the simplest ratio. Cannot simplify it any further, gives us the empirical formula, which I'm going to abbreviate EF. The molecular formula, if it is different than the empirical formula, is going to be a whole number multiple, and we can figure that out if we have the molar mass. So here we have a compound. We've already figured out its empirical formula. The work that we did on the previous question, we've already done all that work. Simplest ratio C2H5N. That's the empirical formula. But we're given the information that it has the molar mass of 129. So we can use that to figure out its molecular formula. We must have the molar mass in order to do this. So the first step is to take your empirical formula and calculate its molar mass. So 2 carbons, 5 hydrogens, 1 nitrogen. This has a molar mass of 43. So then we look at the molecular formula and we're told that it has a molar mass of 129, and we have to figure out what the multiple is. How many times does 43 go into 129? I multiply by 3. So 43 times 3 is 129. If I couldn't see this by inspection, I could take the 129, divide it by 43, and I'm going to get 3. It has to be a whole number ratio or something is wrong. So whatever we do to the numbers, which we figured out with the molar masses, this factor of 3 has to be applied to the formula. So we must multiply our empirical formula by 3, which means I take a 3 times all the atoms in the empirical formula, which gives me C6, H15, N3. This is my molecular formula. Okay, so the next few pages, the next few problems are practice. Go through, if you're given the percent data, like in this one, and figure out what the empirical formula is. You don't have any more information here, so you cannot figure out the molecular formula. You're just going to figure out the empirical formula. Stop the video, work through the problems, and then turn it back on and check your work. Okay, so take the percent data, turn it to grams, divide by the molar mass of each element. That gives us a decimal form of the moles. Do not round in the middle. Pick the smallest one, divide each of them by whichever is smallest, and then hopefully you get whole numbers. In this case, 4 and 1 and 1, which means our empirical formula is 1 potassium, 1 manganese, and 4 oxygens, KMnO4. Okay, the next problem, the data is given in a different form. Instead of having percents, it's given in grams. So 1.91 is the number of grams of vanadium, which is V, and 1.50 is the number of grams of oxygen. So there's no first step where we take our percents and change them to G. Here we're going to start out directly with grams, but the rest of the steps are exactly the same. Divide by molar mass, divide by the smallest number. Stop your video, work through this problem, and then turn it back on to check your work. All right, at this point we have done the first 2 steps, gone from grams to moles in both cases, picked the smaller one, which is 0.03750, divided both by that smaller number, and we get a 1 and a 2.5. You cannot round 2.5 to 3. It is not close enough. It has to be really close to a whole number. However, what can we do to 2.5 to get it to the closest whole number? We can multiply it by 2. If we multiply 2.5 by 2, we have to multiply everything by 2 because we have to do the same thing always to both numbers. So we multiply it by 2 times 2 equals 5. 1 times 2 equals 2. So our empirical formula is V2 Okay, last one. Here, again, we're given the empirical formula. It is CH2O, so we've already done all of the empirical formula work, and its molar mass is 60.05. What's the molecular formula? So the empirical formula has a molar mass of 30.02. How does this compare to 60.05, which is the molecular formula? Divide 60.05 by 30.02, and we see that the factor is 2. Sometimes you can tell this by inspection. If not, you can work out the math. So 2 is the factor. I'm going to take my empirical formula, multiply everything by 2, and I get C2H4O2. That is the molecular formula.